Good morning children. Today we will discuss about acids, bases 1. First we will see about base. In the previous class we have learned about acids, isn't it? So now we will see about base. What do you mean by base? In our day-to-day life we use soaps for bathing purpose as well as for washing purpose. Soaps are slippery in nature. It means slippery means it is very difficult to hold firmly. So soaps are slippery in nature. Do you know why? Soaps are slippery. This is due to the presence of base. Okay. So base is a chemical substance which is corrosive as well as it has bitter to taste, right? A lot of bleachers, soaps, detergents contains base. So a base is a chemical substance which releases hydroxyl ions when dissolved in water. In the previous class, we have learned that acid is a chemical substance which releases hydrogen ions in water, isn't it? But for base is a chemical substance which releases hydroxyl ions when dissolved in water. This is the definition for base, right? Okay. So, for example, you can take sodium hydroxide, potassium hydroxide, ammonium hydroxide, calcium hydroxide. These are some of the examples for bases, right? Sodium hydroxide, when dissolved in water, it forms sodium ion as well as it releases hydroxide ion. Okay. What is the formula for sodium hydroxide? It is NaOH. So NaOH is sodium hydroxide. When dissolved in water, it forms sodium ion, that is Na plus ion as well as OH minus ion. This OH minus is nothing but the hydroxyl ion, right? Next, potassium hydroxide. Potassium hydroxide, when it dissolves in water, it forms potassium ion. Along with that, hydroxide ion is released. Okay. So, the formula of potassium hydroxide is KOH, right? So, KOH on treating with water, it forms K plus ion. K plus ion is nothing but potassium ion. Along with that, OH minus ion, that is hydroxyl ion is released. Okay. So, a base is a chemical substance which release hydroxide ions when dissolved in water. This is the definition for base. Okay. Right. So, next let me discuss about the strong acids and strong bases. Strong acid as well as strong bases both are 100% dissociation into ions. What is the meaning for dissociation? Dissociation means separate into ions. Okay. For strong acids we can give examples sulfuric acid, hydrochloric acid, nitric acid. These acids are 100% dissociated into ions. Okay. Right? So, strong acids as well as bases. Strong bases examples are sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide. These are strong bases. These strong bases are also 100% dissociated into ions. Okay. Next one, weak acids as well as weak bases. Weak acids means acetic acid, carbonic acid or weak acids, and weak base is ammonia. These weak acids as well as weak bases are partially means not fully, not completely. Okay, part level only it will dissociate into ions. So this point also you have to remember, right? Strong acids as well as strong bases are 100% dissociation into ions. Dissociation means separate into ions. Whereas weak acids as well as weak bases are partial dissociation only takes place here. Okay, right. Next we can move to strong bases. What do you mean by strong bases? The bases which completely ionize in aqueous solution to give hydroxide ions. Hydroxide ion means that is OH minus. Hydrogen ion means what is the formula we have to write? H plus. H plus is hydrogen ions, whereas OH minus is hydroxyl ion. Okay, are called strong bases. Once again I repeat, strong bases are bases which completely ionize in aqueous solution. Aqueous solution means the solution in which water acts as a solvent, right? So the bases which completely ionize in aqueous solution to give hydroxide ions, that is OH minus, are called strong bases. Okay. Example: sodium hydroxide, potassium hydroxide, ammonium hydroxide, calcium hydroxide. These are the strong bases. Okay. Next one, water soluble bases are called alkalis. Okay. For example, the same example we can take sodium hydroxide, potassium hydroxide, ammonium hydroxide, calcium hydroxide. These substances are highly soluble in water. Hence, they are called alkalis. Okay, they are called alkalis. Okay. Next, we can move to weak bases. What do you mean by weak bases? Right. The bases which ionize to small extent, minimum level only in aqueous solution to give hydroxide ions, that is OH minus ion, are called weak bases. Okay. What is meant by weak base? The bases which ionize to small extent in aqueous solution to give hydroxide ion. Strong base means what? The bases which completely ionize in aqueous solution. But for weak base, it is partially ionized in aqueous solution. That is the difference between strong base and weak base. Okay. So weak bases are bases which ionize to small extent in aqueous solution to give hydroxide ions, that is OH minus ion, are called weak bases. Okay. Example: ammonium hydroxide. NH4OH is ammonium hydroxide. Here you have to write the name of the particular compound. Okay, compound name you have to write. This compound is ammonium hydroxide. So that name you have to mention here. Ammonium hydroxide, that is aqueous solution. Aqueous solution means this ammonium hydroxide is dissolved in water, gives ammonium ion plus OH minus ion, that is hydroxide ion. Okay. And next one, calcium hydroxide. What is the formula for calcium hydroxide? It is Ca into OH twice. Okay. So calcium hydroxide, that is also in aqueous solution, gives calcium ion Ca2 plus, along with that hydroxide ions will produce. Okay. So what do you mean by weak base? The bases which are ionized to small extent in aqueous solution to give hydroxide ion are called weak bases. Okay. Example: ammonium hydroxide as well as calcium hydroxide. Next we can move to acidity or hydroxicity of base. Okay, acidity or hydroxicity of base. So we can classify the bases into three types. One is the monoacidic bases, diacidic bases and triacidic bases. Okay. these are the three types of bases: monoacidic base, diacidic base and triacidic base. These are the three types of bases. Monoacidic base means the base which contain only one hydroxyl group is called hydroxyl ion is called monoacidic base. Okay, the base which contain only one hydroxyl ion are called monoacidic base. For example, sodium hydroxide, potassium hydroxide, ammonium hydroxide. These are the examples for monoacidic base because these base contain only one hydroxyl group. Formula for sodium hydroxide is NaOH, only one hydroxyl group. Potassium hydroxide, KOH, one hydroxyl group. Ammonium hydroxide, NH4OH, one hydroxyl group. Okay, so the base which contain only one hydroxyl group are called monoacidic base. Second one, diacidic base. Diacidic base means the base which contain two hydroxyl ion are called diacidic base. Okay, the base which contain two hydroxyl groups. For example, calcium hydroxide, magnesium hydroxide. The formula for calcium hydroxide is Ca into OH twice. Okay, two hydroxyl groups are here. Whereas if you take magnesium hydroxide, the formula is Mg into OH twice. How many hydroxyl groups are here? Two hydroxyl groups, right? So the base which contains two hydroxyl ion are called diacidic base. Then what about triacidic base? Of course, the base which contain three hydroxyl groups are called triacidic base. Example, aluminium hydroxide, Al into OH thrice, ferric hydroxide, Fe into OH thrice. Okay, so aluminium hydroxide, ferric hydroxide will come under triacidic base because here the base which contain three hydroxyl groups. Okay, so acidity or hydroxicity of base, it can be classified into three types. One is monoacidic base, diacidic base and triacidic base. Monoacidic base means the base contains only one hydroxyl ion. Diacidic means base which contain di means two hydroxyl ion. Triacidic base, the base which contain tri means three hydroxyl ion are called triacidic base. Got it, children? Right. So next we can move to the chemical properties of bases on reaction with acids, other things, metallic oxides, non-metallic oxides, like that. First let me discuss about the reaction with acids. Okay, reaction with acids. Actually this is a neutralization reaction because this base when react with acid, it produces salt, along with that water is formed. Okay, so it is a neutralization reaction. Already we learned this in for acids also, isn't it? Here instead of acid we are learning about base. So NaOH is sodium hydroxide plus HCl is hydrochloric acid. Reaction of base with acid. Okay, base when react with acid, NaOH is a base, sodium hydroxide is a base, HCl is a acid. So sodium hydroxide when it reacts with the hydrochloric acid, both react to form a salt. What is the name of the salt? That is sodium chloride. What is the formula for sodium chloride? NaCl. Okay, along with that water is formed. Here sodium hydroxide, hydrochloric acid, these are in aqueous solution, that is dissolved with water. Okay, so base, that is sodium hydroxide, when it reacts with the hydrochloric acid, both combines to form a new compound, sodium chloride. Sodium chloride is a salt, along with that water is formed, hence it is called a neutralization reaction. Okay, here below the formula you have to mention the element name or compound name you have to mention. This NaOH is sodium hydroxide, isn't it? Here you have to mention the compound name. HCl is hydrochloric acid. Here also you have to mention the name. NaCl is sodium chloride. Don't simply write salt. First you mention sodium chloride. Below you mention, you put it in the bracket salt. And then water. Water it is in a liquid form only. So the physical state also you have to mention. Got it? Right. So next one. Again, base when it react with sulfuric acid. Okay. First we saw hydrochloric acid, isn't it? Next we will see the reaction with the base with sulfuric acid. So two molecules of sodium hydroxide when it reacts with sulfuric acid. What is the formula for sulfuric acid? H2SO4. Both react to form a salt, sodium sulfate. Okay, and the formula for sodium sulfate is Na2SO4. It is a salt because it is salt is producing means that is called the neutralization reaction. Along with that, water is formed, 2H2O. Okay, so here also sodium hydroxide as well as sulfuric acid both are in the aqueous form, right? Next one is calcium hydroxide. Calcium hydroxide formula is Ca into, right? Now we can see the reaction of bases with metals. Sodium hydroxide when it reacts with zinc. Zinc is a metal. Sodium hydroxide when it reacts with zinc, both react to form a compound Na2ZnO2. This compound name is sodium zincate. Okay, sodium zincate plus along with that hydrogen gases released. Okay, so sodium hydroxide when it reacts with metal, they combine to form a new compound sodium zincate plus hydrogen gases released. Next, reaction of bases with non-metal oxide. Non-metals means carbon, hydrogen, oxygen, nitrogen. These are non-metals. See, sodium hydroxide when it reacts with carbon dioxide. Carbon dioxide is a non-metal. Both react to form sodium carbonate. Na2CO3 is sodium carbonate plus water is formed, right? So sodium hydroxide is a solid. Its physical state is solid. Carbon dioxide is a gas. Sodium carbonate, it is in the aqueous solution, that is dissolved in water, right? Next one, calcium hydroxide. Calcium hydroxide is a base. The formula of calcium hydroxide is Ca into OH twice. So CaOH twice plus carbon dioxide both react to form calcium carbonate salt. Okay, calcium carbonate salt. CaCO3 is calcium carbonate plus H2O is formed. Okay. Next one, reaction of bases with heavy metal salts. Right. This is ZnSO4 is zinc sulfate. It is a heavy metal salt. So this heavy metal salt when reacts with this base sodium hydroxide, they combine to form a compound sodium sulfate. Na2SO4 is sodium sulfate plus zinc hydroxide is formed. Okay, so this zinc hydroxide is actually white precipitate. It is in precipitate form. Okay, the color of the precipitate is white precipitate. So reaction of bases with heavy metal salts produces precipitates. Okay, so ZnSO4 zinc sulfate react with NaOH sodium hydroxide combines to form sodium sulfate Na2SO4 plus zinc hydroxide will form ZnOH twice. Okay, so this is a white precipitate salt. Next, FeCl2. hydroxide. The formula of magnesium hydroxide is MgOH twice. It is a salt. It is in the solid form. So this magnesium hydroxide on treating with water, they combine to form magnesium ion Mg2 plus ion plus 2 hydroxyl group, 2 OH minus ion will form. Got it? So these are some of the chemical nature of bases. Okay, right. Next we can move to Arrhenius concept for bases. In the previous class we learned about the Arrhenius concept theory based on acids. According to Arrhenius theory, an acid is a substance that releases H plus ions, hydrogen ions in water, isn't it? But here for bases are the substances which dissociate in aqueous solution to generate OH minus ion. For acid means it releases hydrogen ion H plus, whereas for base it releases hydroxide ion OH minus ion with water, right? So according to Arrhenius concept, bases are the substances which dissociate, that is separate in aqueous solution to generate OH minus ions. Okay. For example, we can take potassium hydroxide, KOH, potassium hydroxide. It is a solid. This on treating with water, they combine to produce K plus ion, potassium ion plus hydroxide ion, OH minus ion, right? And ammonium hydroxide, NH4OH, it is also a solid, right? So this ammonium hydroxide on treating with water, they combine to form ammonium ion, NH4 plus ion plus OH minus ion will release. Okay, so base is not Arrhenius concept for bases means actually when it is treated with base, when it is treated with water, it releases OH minus ions. Okay, if it is H plus ion means that is it releases the hydrogen ions. OH minus means that is base, hydroxide ions. So according to Arrhenius concept, bases are the substances which dissociate in aqueous solution to generate OH minus ions. Got it? Right. Next we can move to the applications of Arrhenius concept. What are the various applications of Arrhenius concept? First, Arrhenius concept explains the acidic nature of aqueous solutions of non-metallic oxides. Okay. Arrhenius concept explains the acidic nature of aqueous solutions of non-metallic oxide. Non-metallic oxide example, carbon dioxide, sulfur dioxide, sulfur trioxide, nitrogen dinitrogen pentoxide. These are some of the non-metallic oxides. Okay, so this Arrhenius concept explains the acidic nature of aqueous solution of the non-metallic oxides such as carbon dioxide, sulfur dioxide, dinitrogen pentoxide, etc. Okay. Next one, Arrhenius concept explains the basic nature of aqueous solutions of substances like metal hydroxide. For example, sodium oxide Na2O, calcium oxide CaO. Okay. So Arrhenius concept explains the basic nature of aqueous solutions of substances like metal hydroxide. Next one is water is amphoteric. Amphoteric means it releases both H plus as well as acidic as well as basic nature. Okay, it explains acidic as well as basic nature. So water is amphoteric and provides both H plus and OH minus ions in aqueous solution. Okay, water is amphoteric and provides both H plus and OH minus ion. Next one is now neutralization reaction. Neutralization reaction is a reaction between H plus and OH minus ions to form a water. Okay, so this is a neutralization reaction. are used in many purposes, not only in industrial purposes, many uses are there. First, let us see the sodium hydroxide. Sodium hydroxide is otherwise known as caustic soda. Sodium hydroxide is mainly used for the preparation of soap. It is used in paper industry, okay, and textile industry, and apart from that, it is also used in petrol refining also, okay, petrol refining, and mainly it is used as a laboratory reagent. Next, KOH. KOH is potassium hydroxide. Potassium hydroxide is otherwise known as caustic potash. It is mainly used in alkaline batteries, and also it is used for making soft soaps. Okay. Next one is calcium hydroxide, Ca into OH twice. Calcium hydroxide is otherwise known as slate lime. It is mainly used for whitewashing, and calcium hydroxide is mainly used for the preparation of whitewashing purpose we are using, and apart from that, calcium hydroxide is used for the manufacture of bleaching powder, okay, manufacture of bleaching powder, and also it is used as a laboratory reagent. Next one is magnesium hydroxide. Magnesium hydroxide, it is otherwise known as milk of magnesia. It is an antacid which is used to remove the excess acid which is present in the stomach. Okay, for indigestion purpose, we will take magnesium hydroxide. That is why we are saying it is called milk of magnesia. Next one is ammonium hydroxide. Ammonium hydroxide is mainly used for the preparation of fertilizers. For fertilizer purpose, we use ammonium hydroxide, and also it is used for window cleaning, to clean dark stains which is found on the clothes or otherwise in some other areas. For this, and also it is used for the manufacture of rubber, plastics, etc. Okay, so these are some of the industrial uses of bases, children. You can expect this industrial uses of bases in 5-mark question or otherwise in 2-mark question. So according to that, you have to learn fully. You don't simply write NaOH